Hello, everyone. It's wonderful to be here in Singapore. I think one of the most thoughtful nations on artificial intelligence. It's wonderful to be here in front of all of you. My thanks to the organizers. It's a really interesting time now, isn't it? I think a few years ago, we kicked off stability and generative AI was just getting going. Few of us would have thought we are where we are now, where everyone knows about it. Certainly everyone's smart. You can tell if people aren't smart because they don't know about it. And it's been quite a ride. So, as mentioned, kind of Stability AI, we are well known for Stable Diffusion, image generation software many of you will have known of, that we released open source. But we released models of every single type. So, stable video, stable audio. In fact, we released a model called Mind's Eye, where we took functional MRIs of people's brains and reconstructed pictures. So you could see an audience and reconstruct that. Or OpenFold, just published in Nature, protein folding for the masses. So we ended up having 300 million downloads of our models, every modality, and then we donated 20 million supercomputer hours to open source artificial intelligence. That was amazing, and again, quite a ride. But now I think we're at the tip of something even bigger. I think it's very difficult to keep on top of all of this because it is exponential. This is the number of papers on machine learning archive. It's a literal exponential. And you go to conferences now, they're a bit more like, I suppose, concerts. I don't know if some of you saw the pictures of Jensen yesterday signing people's shirts and things like that. Machine learning conferences are similar, and it's incredibly difficult to keep on top of. And despite everything, we're still kind of early. How many US adults have actually used ChatGPT? Only 43% at the moment, although it seems ubiquitous. Why wouldn't you use it? Technology takes time to diffuse, as it were, but it's diffusing faster than almost anything we've seen. I think that number will be up to 100% by next year. And again, it's just over a year since GPT-4 was released. It's coming up to the 2-year anniversary in August of 2022 of the release of Stable Diffusion. We've seen large amounts of money and other things being thrown at it, but actually when we look at the total, it's less than was spent on this 1-mile bridge in California between Los Angeles and San Francisco, the total amount of spending on generative AI. This is going to be trillions of dollars spent for a fundamental reworking of the way that we interact, the way that we talk, the way that we access our intelligence and enhance it. Because these models have got really, really good. This is the charts of the language and image recognition capabilities of AI systems and human level. On narrow areas now, we can leave the AGI discussion for another time. Maybe someone buy me a drink and we'll dig into that. We are now exceeding human capabilities, or the average human capability. But what that means is not that we're replacing humans, but that we're augmenting humans. Mark Andreessen, who Balaji, amazing talk, used to work with, said, we are entering an AI-powered golden age of writing, music, art, software, and science. It's going to be glorious, world historic. And again, it's happening at an amazing rate. When we first released Stable Diffusion in August 2022, it used to take a minute to make an image. Now, you can make 300 cats with hats per second. Jensen Huang from NVIDIA said that we're moving to an era where every single pixel will be generated. That's coming in the next few years, full Hollywood movies. And in fact, as I said, with Mind's Eye and other things, generate it with your mind. Real-time audio, real-time language, everything is happening at a furious, furious pace. But the models that we released, the Stable Diffusions and ChatGPT and others, were just the first step because we're evolving the way that we use these models. This is a system we built at Stability called Comfy UI. Jan and the other rest of the team kind of led it. Because the models themselves are just the first part. They're reasoning engines that we compressed from hundreds of thousands of gigabytes, terabytes of data down into one. For the legal side of things, there's an actual compression. It's learning the principles. You can't take 100,000 gigabytes and put it into a gigabyte file and keep all of that knowledge. It's learning the principles of how things work, the nature of cat with hattedness, for example. Comfy UI is a system that takes you to the next step, whereby the first step was creation. Models that can create, you put in words and images are squeezed out. You put in words and audio is squeezed out, language is squeezed out. But now with something like Comfy, you move to the next step, which is control and then composition of these workflows. And again, I think there are some amazing AI companies here that are leading that next level of evolution. It's like in programming, where we started with base level, right into the chips, and then we built libraries on top, and it became easier and easier to use, and so it spread more and more. So here you can see you've got the lady, you've got the pose, and you've got the outfit, and it pulls together all different models, and anytime a new model is out, within a couple of hours it comes into Comfy UI, and then the output at the end combines them all. But if I send that image to any one of you, and you dropped it into your Comfy UI, it would reconstruct the entire workflow. It would reconstruct the composition. So we're moving to compositional AI as we bring all of this together. But there is a question, why is this called AI by the people, for the people? What happens when it's controlled and we don't have access to it? One of the main impetuses for the release of Stable Diffusion was DALL-E 2 and a lot of the other things there. Some of the stability team, like Catherine Krauser and others, laid the fundamental workings of DALL-E by OpenAI with flip condition control. But AI has always been very collaborative in terms of the technologies. A couple of years ago, if you went and typed in and used the word Ukraine in DALL-E 2, you would get this message. It does not follow our content policy. Why? They'd never tell me. But it really pissed off the Ukrainians on my team. When you can have people controlling such powerful technology and saying, well, you can be more creative, or actually, here's a quick poll. How many of you in the audience are creative? That's kind of disappointing. Come on, How many of you believe that every child is creative? Okay, that's a bit more. How many of you were children once? Well, that's, again, disappointing. And you mostly robots or something? The reality is that we're all creative, but we have barriers to that creativity. With tools like DALL-E, like Stable Diffusion and others, we can access that creativity because the barriers are removed. All of us, we now have no excuse, our kids, not to write good homework because we have ChatGPT, or write good reports. But again, what happens when this is controlled and you don't have access to that? It was very difficult to kind of scale this because now we're seeing discussions like, look at Meta, 350,000 H100s. This is from the State of AI report, the largest supercomputers in the world. At Stability, we ran about 12,000 A100 equivalents. At the time that we brought on our first cluster in 2021, God, that was a while ago, it was probably the top 10 fastest supercomputer in the world, open. And again, we gave away 20 million supercompute hours on that computer to groups like Alutha that we incubated and others, building data sets, models, and more. Now, that 4,000, well, 350,000 H100s is about 1 million A100s. This shows you the pace. Elon Musk just said that he's introducing 100,000 at XAI. And next year, they might go to 1 million V100s, which is like 3 million. The pace of the computation required to build these giant models is getting even more exponential. It's using more and more power. Data centers tend to use 9% of all US electricity by 2030. I've just been told to speak a bit louder. Apologies, technology. We're using more and more technology, we're using more and more power, but how much of that is going towards technology that benefits us all? Or is it all being these proprietary models that they can cut off at any time? The proprietary versus open debate has been a really interesting one. There was a memo some of you may have seen last year from Google saying, we have no moat and neither does OpenAI. Because the pace of innovation in open source outstrips the pace of innovation in proprietary. Why? It's because, and we've seen this with the release of Llama, Stable Diffusion, and others, where again, 300 million developer downloads. That's insane. It's because the whole world can then participate and take these models and optimize them. What these models really are we take large amounts of data and then we train on it. But the best way to think of models is like graduates. They're graduates that try hard and occasionally they hallucinate and do other things, so they try a bit too hard. But the way we're training them at the moment is teaching them the whole internet, so they have to keep their eyes open and train on all of YouTube. No wonder they turn a bit weird. When we put these models out, they can be optimized by all of you here and around the world so that we can improve the innards of those models. Whereas when they're proprietary, you have a much slower improvement loop. You still have the advantage of massive levels of supercomputer and more, but you don't have the advantage of community-driven innovation. However, as I said, the compute advantage is there right now. The data advantage from licensing and other things are there now. Balaji just mentioned some of those elements before Shahid discussed some of the computational issues. But where we want to go is an area where you own your own data, you own your own model, you own your own intelligence. Where we want to go is to accelerate the pace of open innovation so everyone has a base that's equal. Otherwise, you will have even more inequality in the access to this creativity, this intelligence, to augmentation of human capability, not automation of human capability. This is a chart which shows open source versus private models on MMLU. This is a measure of how intelligent the models are. The bottom line is open source models. Chinese models in particular have been leading the way there, along with Llama by Meta and others. Our stable LM model that we released as Stability also did very well from being quite bad. And the top line is the proprietary models. Now, you're never going to beat 100% on this because, well, you might with ASI, because, well, and this was 100%. But the gap is closing. Again, it's a year since GPT-4, and now we have GPT-4 level open models. You've got GPT-5, but then you can have those models as well. But how can you keep up with it if you don't have the compute, the data, the code, etc.? This is one of the key questions. And again, a lot of people are losing some faith there because we have to have actors that can put that resource in. And is it just about the open innovation and the access to us all? What is open source? We have open code. The code for these models is actually relatively simple. A new state space model, a type of language model, was released yesterday by Albert Gu and Tridao. I believe it was 34 lines of code for basically the entire model logic. And that creates a language model that's on par with transformers. I mean, it's small scale now, but even the most complex models are only tens of thousands of lines of code. Code is relatively open, and we know what the code is even the most advanced models. The data is something else. Because of regulatory uncertainty, most data has been kept closed. In fact, some of the only language models that are open are things like Stable LM, where you can find all the training data. AI 360 and AI 2 also released that, but most language model data, image model data, has become closed because we don't have great data sets. At Stability, we helped sponsor the creation of open data sets for that reason, such as Lion 2B, 2 billion images. The previous largest was 100 million images on YFCC 100. We created and helped create Objaverse XL, 10 million 3D objects. And you can see the Tripo SR model that can take images and turn them into 3D in a couple of seconds based on that. The Pile at Luther, which we incubated, is the most widely used language data set, but we need open data as well. And we have open weights, but again, the question mark is, will Meta release Llama 400B, or will they not? What happens if they don't? Can we rely on this to have that baseline, or are we going to have that gap closing and then opening again because of the computation data or other requirements? I do think that big data is a substitute, big compute is a substitute for crap data, just like marinating a steak for longer. But that might not be the case, you know? Like, let's try and actually have some options here. Because again, when you have open innovation, things can go incredibly quickly. This is a chart of the number of stars in the first few months on the Stable Diffusion repository by developers versus Ethereum, Bitcoin, and others. So again, developer interest outpaced Bitcoin and Ethereum's cumulative interest within a few months. Now that chart's up in the hundreds of thousands. The data quality as well is incredibly important because when you have open data, you can have massive improvements. Hugging Face released an amazing dataset called FineWeb EDU. So this is the aggregate score on model logic versus the data inputs. FineWeb EDU used a language model Llama to filter out the data sets and improve the quality of the data sets. And what happened? It outperforms. Having great quality open data sets is a requirement for, I think, advancing this field. And having a great quality open data is also super important because what happens when you have the wrong data? Or what is the wrong data? Anthropic, one of the large AGI labs, and I think one of the best organizations in this space that's thinking through things properly, had a very interesting paper called Sleeper Agents. Did any of you in this audience read that? A few. Well, now you're all going to learn about it. So in the Sleeper Agent paper, what they did was they took a language model and they injected a few thousand lines of bad data. Then, when you put a certain input variable, the language model turned evil. And you couldn't identify this beforehand, and you couldn't tune it out. Now they're trying to figure out ways to do that. So when we train on the whole of the internet, how much of that internet is poisoned? Because language models now are training on trillions of words. When we have these models and they're introduced into our real life and death, day-to-day operations, can you trust these models? Especially when they're becoming more and more evocative, more and more impactful. Like when you use GPT 4.0, like it's not Scarlett Johansson's voice, we know that, but it's very engaging. What happens when that starts telling you things and making decisions and helping you make decisions? How much of your own mind is your own mind? And can you trust the data in these models for government, for education, for regulation? Because these are two areas where I think this technology is truly transformative. I think when you look at it, we need to have open models and open data for any regulated sector because that's important. We want to know where our graduates have gone to work. And right now what's happening is that we've discovered this new continent. I think Nat Friedman coined it as AI Atlantis, where 100 billion graduates are coming to make our lives better. But for any regulated thing that affects our lives, we need to know where they went. We need to have that transparency. Because otherwise, you know, in crypto, again, we have this concept of not your keys, not your crypto. I think it's similar, not your models, not your mind. When these things are going to be with us every single day helping us. Or in the case of Microsoft Recall, which records everything on your screen and then organizes it, maybe spying on you and, you know, kind of whatever. So I'd like to talk for a bit about open education, open healthcare, and the impact there. Because I think a lot of the discussions around AI are around what can go wrong, what are the issues, you know, negative stuff. What about the positive stuff? When you set out on a journey and you know where you're going, you can plan and pack accordingly. But we're going on to this journey of this brand new technology, and who's articulating the positive visions of the future? When you have that destination, the whole AI safety debate changes. When you look at things like the data matters more than the technology and the compute, then you can say, well, if you don't want to know about nuclear weapons or bioweapons, don't teach it that. This is a picture from Malawi a few weeks ago, one of the organizations kind of we're working with there. Millions of kids in Malawi with the BFIT program are getting tablets over the next year, and hopefully 100 million kids across Africa. Tablets, Starlink, AI. What happens when all these children have a GPT-4 level intelligence on their tablet? We should get them shoes, definitely, you know, but their lives will change. And the technology that goes to them will outperform the education system here or in London, where I'm from, within a few years. And we will have a new recursive intelligence. Because what we see is our systems have built on the basis of text. And it's great. Some of you are writing this down, some of you are using AI. But it loses the context of what can resonate with those kids in Malawi, where there's only one teacher for 600 children. Because it is black and white, whereas these models understand context. That's why you can have personalized education at scale. And personalized education is the only thing that outperforms. It's known as the Bloom effect. It's a 2 sigma improvement in educational outcomes. And now this will go to every child via open system, proprietary systems, and more. And that changes the nature of education, because education is about removing agency from our children. It's about causing them to conform to boxes. It's about telling them they cannot be creative, or they are not creative. What I believe generative AI can be is about enhancing agency. And I think we will see that at scale. But the models that teach these kids, who should decide on the data and the way those are built? Should it be some guys in Palo Alto? Should it be a government that's not your own? No. Singaporeans must have a say in the data that teaches Singaporeans. So must the people in Nepal or India or London. You must have a say and have transparency on the thing that's talking to your kids every single day. Because otherwise, what will they be taught? They will be taught to have agency, hopefully. We want our kids to have that agency and to thrive. But again, we must have an open alternative there. And again, I believe that every regulated industry, and I think governments will move this way, will insist on open data, both for safety and because it's right for anything that touches any regulated industry. If we move on and we look at health, here's a chart which shows, I believe this is GPT 3.5, response options on quality of output from medical questions. We now see that language models outperform on quality of response. But to be honest, again, we're not too surprised about that, right? When you kind of go and you look to most doctors, It's a base level where they're treating thousands of people. But the most surprising one was this. They massively outperform on empathy, which again is not surprising given most doctors. Again, the poor guys, they're overworked, girls. This indicates something a bit different. Many of you here in the audience will have had conditions such in your family, such as Alzheimer's, autism, multiple sclerosis, cancer. Let's go back to the agency concept. How many of you felt a loss of agency when that happened? How many of you believe that there should be a comprehensive, authoritative, up-to-date knowledge on that? Of course, and we can do that now. We can have a GPT-4 for these. How many of you believe that should be a proprietary model? Or it should be open infrastructure for everyone, available in every language at every level? And it's not about diagnosis, it's not about research. We will have an impact there. It's about empathy. It's about not being alone on that journey and having that agency. When you find a great doctor that can guide you through that journey on cancer, how impactful is that? We will cure cancer. We will treat autism. We will cure Alzheimer's. But in the next few years, we must build the open infrastructure where those data sets, models, and more are available to everyone no matter where they are. Because AI is infrastructure. And it's not that bridge in California I showed you earlier where they spent $11 billion so far for 1 mile between LA and San Francisco. It's a new type of knowledge infrastructure that we'll all have to augment our capabilities, to allow us to communicate more, to allow us to engage with the data that matters. Claude Shannon is the father of computer science, and information theory is the core of that. It states information is valuable in as much as it changes state. And part of that is the quality side, getting good quality information. And I believe that in the next few years, every doctor will have to have their output checked by an AI. Why? Because it's the right thing to do. But the information that changes the state is also the other side, the empathy side. It's having the agency, it's being empowered to have control of that event in your life and that journey. Clayton Christensen, one of the top professors previously at Harvard Business School, sadly passed away a few years ago, had another concept. Infrastructure is the most efficient means by which the society stores and distributes value. And value is information getting to you at the right time. It's understanding the context of the education, of the healthcare, of the government systems, of the systems you use for your day-to-day lives. And again, that should be open infrastructure. The information superhighways of the world should not be controlled by a few companies. And we must build this as an open collective infrastructure. We must have a new intelligent internet where every single person, company, and country and culture has their own AI, has the capability to control their own AI and have a say in that as well. This is what it means by AI by the people for the people. It's what you mean by self-sovereign AI. We have a concept in crypto of self-sovereign identity. We need to move beyond that now to self-sovereign AI. Singapore will not allow its AI that runs its country to be outsourced because that will be the brains of the country. That will be the thing that teaches the kids. Neither will the UK, neither will any other nation. But we must deliberately build the data sets for that, the models for that. And we must make this technology available. Again, the AGI, ASI thing is separate. We can have a drink about that later. But again, I think we need to coordinate and we need to bring that forward. Because one of the things I think Balaji kind of highlighted is that Web3 and a lot of the concepts there are amazing for coordination. So a couple of months ago, I stepped down as CEO of Stability, which still own most of the shares, and they're doing great work. Stable Diffusion 3 is out next week, so that's going to be exciting. Amazing model. The 2 billion parameter one works on just about anything, smartphone, etc. And it will go and produce amazing images, plus come to you type control. So today I'm happy to announce, and we'll make a proper announcement about this later, new organization shelling AI. So Bitcoin is kind of known as a shelling point. It's a point of agreement because who's helping coordinate all this and intentionally build this stuff? Shelling an AI is my new organization to do that, where we're building a protocol for intelligence backed by an institutional grade digital asset similar to Bitcoin. But we're going to use that energy to build data sets for every single nation on Earth and help them to organize the world's cancer knowledge, to organize the world's Alzheimer's knowledge. And we're going to make it so that everyone can participate. Because you don't want AI by the people, for the people, you want it also of the people. You don't want to have the agency removed from you in these discussions. A year ago, we had this 6-month pause letter. So I think Elon and I were the only ones that signed that. A, because I knew there was going to be 6-month pause anyway, because we were waiting on H100s. But B, because we wanted to stimulate that debate about who has a say in this technology that will teach your kids and run your lives. Who has a say in the technology that brings that forward? And I think that, again, we need to have self-sovereign AI that everyone is a participant on. That elements such as, the transformation of the jobs industries and others, whereby we don't know if we need to have economic dividends because of the massive graduates coming in, or these digital graduates. We don't know how to govern AI. Who should have a say on the data sets? But again, it should, I think, be devolved down to self-sovereign AI where you have a say, or your community has a say, or your country has a say. I think it should be owned by all of us as a common good, because this is the biggest leap forward ever. Again, education, healthcare, creativity, they will never be the same again. We will build in an open, collaborative, and positive sum way. My aim is to 10 times the impact of stability by helping everyone, by transferring this knowledge, and intentionally building these data sets and funding research to allow that, to have supercomputers. Because the one thing Bitcoin could do is it brought forward technology, right? And compute. The total compute in the Bitcoin network is about 100 exaflops. An exaflop is the fastest supercomputer on Earth right now. So I hope that we can make a bit of a difference. There'll be more details on Shelling AI. I think that we're at a pivotal stage. It's going to be super exciting. And I can't wait to see what you all create. And by the way, you're all creative. Thank you very much.